good morning to everyone. First of all, I would like to thank our lecturer, Dr. Devraj, for giving us this wonderful opportunity. Now, I would like to introduce myself and my teammate. Okay, my name is Nivishan and my metric number is MH17060 and my teammate are Anas Ganing, Tanabalan, Muaz and Uziz. Today, I will explain to you all about introduction of our project. Our project is a stimulation testing on Mitsubishi Lancer Evolution 3 piston. Okay, in introduction, there are four subtopics. The first one is the model of vehicle, that is Mitsubishi Lancer Evolution 3, or more commonly known as a Evo 3. Next is the engine type, 4G63E. Next is the introduction about piston, and lastly, the objective of our project. Now let us discuss about the first subtopic of the introduction, the model of the vehicle, Mitsubishi Lancer Evolution 3, or more commonly known as the Evo 3. Evo 3 production was from 1995 to 1996. This car can produce around 201 kilowatt of power at 6,215 rpm and around 309 Newton meter of torque at 3,000 rpm. This car is a all-wheel drive and it's being powered by a turbocharging engine. The power of engine being transferred to the wheel by using a 5-speed manual transmission, and the maximum speed quota is a 180 km per hour. Now I will explain some detailed specification about the chassis. Body type is a 4 or 5-seater sedan saloon. Number of doors are 4. Wheelbase of the vehicle are 2510 mm. The tread front is 1465 mm. Tread rear is 1470 mm. The length of the vehicle are 4310 mm and the width of the chassis are 1695 mm and the height of the vehicle are 1420 mm and the ground clearance is 175 mm and the length wheelbase ratio is 1.72. Lastly, the cab weight of the vehicle is 1216 kilograms. Okay, now let us move to the second subtopic, that is engine type. 4G63T, first introduced in a 1980 Lancer EX2000 turbo car. This engine being manufactured with a single overhead cam and dual overhead cam, but for Evo 3 it used a dual overhead cam. Next is this engine also being manufactured with a natural aspirator or a turbocharging system, but for Evo 3 it used a turbocharging system. Next is this engine being used by the Evolution generation from generation 1 to generation 9. Basically, this engine has been proven for its reliability and extraordinary power output. Now, I will explain some engine specifications. Bore of the engine are 85 mm. Next is the stroke is 88 mm. The rod length is 115 mm. Piston pin size is 22 mm. Total combustion chamber volume 62.8 cc. Each cylinder volume is 499.9 cc. Compression ratio of the engine are 8.5:1. Crankshaft radius is 44 mm. The connecting rod type are IB. The engine classification is inline. Type of fuel is gasoline engine. Number of torque are 4-stroke engine. Type of ignition, spark plug ignition. Number of piston are 4 piston. Motion of the piston is reciprocating and the breathing type is forced induction. Okay, now let us discuss about the third subtopic, the introduction about piston. Okay, piston commonly is a part that is used to transfer the combustion energy to the connecting rod. Piston commonly made of a cast aluminum alloy. because as we know, aluminium alloy is a material that has a high thermal resistance and it was a very durable material. Next is the piston features. Okay, in piston there is a piston head, piston pin ball, piston pin, skirt, ring groove, ring length, and lastly the piston ring. Okay, this is what we call as a piston head. This is the piston pin hole, and this area is called as a piston skirt, and this is the oil ring, and these both grooves are used for the compression ring. And this small hole is a oil drain hole to control the lubrication for the piston. Okay, now let us discuss the last subtopic of the introduction, that is the objective. Okay, the objective of our project are to study about the characteristic of the evolving piston. Next is to study the basic parameter to design a piston, because as we know, to design a piston there are several parameters that has to be considered when designing a piston. Next is to study the characteristic of the piston when using a different material. Because of that, we are run two types of stimulation testing by using a different material. The first material that we use is the cast iron material, and the second one is AISI 1020 aluminum material. Okay, that's all from me. Before I end my presentation, I would like to call our next presenter, Mr. Muaz.
Hello, Assalamualaikum, and good day. My name is Mas Mehudin. I'm his. My metric number is MH17063. Today I will be presenting about methodology about for my group, for our group. So the introduction is in designing any component, there are two major principles in designing. There are two major principles. That is optimization of the product and the safety of the product. So the primary objective in the design of this piston is to convert not this piston but any piston is to convert from chemical energy to useful mechanical energy. And secondly, it is to dissipate heat from the combustion chamber to and secondly is to dissipate heat from the combustion chamber. So by having these two objectives, we have to carefully select our material so that it will dissipate heat better and also can withstand the operating pressure of the engine. So the main object, so flowchart depicting methodology. So for this study, for the objective of this study is to acquire the characteristics of the piston under static condition. The overall study flowchart, this flowchart is as the figure beside me. So firstly, we choose the car model and engine. Then we take measurement. We take the measurement of the piston and then start drawing in SolidWorks. And then we choose the material for testing the piston. In this case, we compare between two materials, and then we use SolidWorks simulation to make a finite element analysis. Then we will generate result when we get the result, and generate result. After generating result, then we will conclude the result. Okay. So we use for design modeling, we use SolidWorks because the workflow has a simple workflow. So we are able to 3D model the piston based on the measurement given. So the main criterion for this piston is to have a high strength so that the piston won't crack during operation. So okay, for the material section, originally the 4G63T inside of the Mitsubishi Evolution 3, the piston was cast iron, but due to we want to know the piston characteristics and to compare between two piston material in maximum bending moment, we search for another material. There are two candidates. First is we selected aluminium. The second is medium carbon steel. For the medium carbon, for the aluminium, based on the criterion that has been put in the slide. So aluminium is good in strength, but compared to steel, it is a bit expensive. So we choose steel because it has good strength with good machinability and it has medium carbon content. Okay. Next is finite element analysis. So for finite element analysis, the software that you use is SolidWorks simulation. Since we have done the model in the SolidWorks, so it will be easy to use its simulation product so that we don't have to interchange between two computer aided design environment or finite element environment. So for finite element analysis, it is used to simulate forces near to the real world condition, operating near to its real operating force. So how the model is the object will be transformed into an element node matrix. So for each element and each node has its own force and force value. From the total node element matrix, the software will generate mesh which consists of those node and element. Yes. So the meshing is done using default software setting because we want to increase the accuracy. So the computer will analyze the element and it will display the result based on the result will be in colored picture, which the highest value is in red, the lowest will be green if I'm not mistaken. So for meshing, just like I said now, using computer generated, using default setting, that software setting, so we can acquire accurate result. So for loading, we use the same loading as the original piston because because um, because due to lack of because we want to compare between two element between two materials, so that we have a comparison which which has a high which is better. And to conclude about this is, so with the final chapter has been final sub so with the final slide has been present, I end my presentation here, and I will pass the baton to my friends. Thank you.
Today, I would like to. My name is Tanabalan, MH17059. I would like to discuss about results, which is crank angle degree versus piston position. And then, so by there you can see, um, okay, this is a four-stroke engine, so it's requires 720 degree to finish the total one complete burn. So each stroke is requires 180 degree where the piston move from TDC to BDC, then BDC to TDC back. Okay, then at first 0 degree the piston is at TDC, then at 180 degree the piston is at BDC. So by there you can see the piston position where the distance is variable. Okay, that's what this graph is showing. Okay, next, crank angle versus piston velocity. Okay, then this is the what by changing the crank angle and each crank angle, what will be the piston velocity. So by here you could see at 180 degree the piston where it changes from TDC, usually 180 degree will be like BDC to TDC. So where the piston position is, it won't move. It's stall. Consider it stall because it's changing its direction from going down then to upwards back. So at 180 degree, it is zero. The velocity is at zero. Then when it's going to like uh, let's say like the 90 degree, there the piston speed is at negative, then it's a positive because of the changes of the crank angle, then the piston velocity is also changing. Then next, crank angle versus piston acceleration. Okay, it shows the piston acceleration at how fast it's moving. So when it's at very at the okay from 0 to 100, it's not even 180, it's around 160, 150 like that. It's at the peak, it's at the here it's at the peak speed here. Then it's consider it's that there is no acceleration, that the speed is constant, then it changes back. So it's just why this thing happened. Okay, because of the piston is not moving, where it's called the crank end float lah. So there will be a end float there where the piston will not be moving, but the crank itself will be moving few degrees. So that's the reason why this straight line here is occurs two times. So why two times? Because again four strokes. So two times two revolution lah, 360 degree once and then another 360 degree once. So total 720 degree. So that's what this graph is showing. And next, this one is kinematic analysis. Okay, kinematic analysis is basically is just the calculation of average piston speed, which is 18.33 meter per second, clearance volume of one piston, instantaneous piston speed, piston position, distance from TDC, instantaneous volume, angular velocity of the connecting rod, and um, furthermore, so just basic one. Uh, just the basic one, the angular acceleration of the connecting rod. Crank angle at the maximum velocity occurs when the crank angle, then maximum velocity of the piston. What will be the maximum velocity is the maximum speed of the piston. So that's what we calculated here, and these are the results there for the all of these questions here. Okay, this one is what we do search for kinematic analysis. Then next, theoretical calculation for piston design. Okay, then the number of working per strokes per minute, where it is 3,125 RPM. Then the maximum cylinder gas pressure. Okay, the maximum pressure which this piston can hold on. That's the 5.8976 Newton per millimeter square. Then cross-sectional area of the cylinder, then indicated power, thickness of the position, piston head on the basis of heat dissipation, the heat flowing through the piston head, the maximum side thrust on the cylinder due to gas pressure, maximum load on the piston due to gas pressure or maximum gas load, maximum bending moment at the center of the pin, maximum bending moment. So these are the answers we get for these all these questions ones. Then simulation results of cast iron pistons. Um, okay, so this is stress. This one the simulation for the stress. So by the photo here, after do the simulation, can see the highest strength part is here, where it's so you can see here a bit greenish here. So it's very stressed at the pin where the pressure all from the on top up here after the combustion chamber or during the combustion chamber when it's in high pressure. So this all pressure is equally distributed to this two area. Here is one, another one is the opposite area, the piston pin area. So that's why it's taking very high stress here. So when design the piston also, that place will have very a lot of meat there. Let's consider the metal will be a lot there. And this one is for the cast iron piston, this simulation. Then the next one is for aluminium, AISI 1020. Okay, and actually aluminium have a bit less stress here if you can see. Uh, Aluminum have a bit less stress here. The color, the green color is a bit less here if we compare to the cast iron one. So yeah, same thing, but just with the different material, we get different results. Thank you.
Hello, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Zaki bin Azman, MH18002. So right now, I will present more about our discussion for our group project. So firstly, we discuss what is inside piston engine analysis. So we gain some parameters, we assume some parameters such as RPM. Then we get result displacement, velocity, and acceleration. Assist by this figure is which has connecting road, gas pressure. Then the next discussion is we make a kinematic analysis. So firstly, we collect information, then we run some tests. At the end, we get some result. Result that we get such as bore, stroke, cone road length, displacement volume, and others. So next, we're going to dynamic analysis. Firstly, we collect some parameter and we assume some parameter. Using formula, we make a calculation and then we get result. So that's all the result that we get, such as bow, cone road length, mass of recording part, the maximum pressure in the cylinder, and others. So the next is theoretical calculation. Firstly, for this one, we collect some parameters and assume RPM. We make an RPM. We assume RPM and then we make calculation. At the end of this, we get some result. Thickness of piston head, bore, brake power, mechanical efficiency, stroke, and some of other result that we get. Here is the result. Next is simulation result. This is the last one, simulation result. So for this simulation result, first we made a comparison between two products, which is cast iron and AISI 1020. Then we make 3 simulation with these two products. We conduct 3 simulation, and after that we get some result, which is in stress, strain, and displacement. Here are the result. So that's all from me. Thank you. Bye.
Okay, hello everyone and good day. As the last presenter of simulation testing on Mitsubishi Lancer Evolution 3 Piston project, I would like to present about the conclusion of this project. First of that, my name is Abdulnas Ghahnim bin Abdul Aziz. This is my number ID, MH17065. Let's go through. First objective are accomplished. There are 3 main objectives in this report, which is first, to study about the characteristic of Evo 3 piston. Number 2, to study about basic parameter to design a piston. And the last, number 3, to study the characteristic of piston when using different material. Okay, after some aspect we took in this analysis, most of the answer are very relevant and satisfactory in this calculation. In terms of simulation, shown some positivity. So there are little review about Evo 3 engine. Its engine was boosted at 270 horsepower at slightly higher revolution, thanks to a new turbine, higher compression ratio, and reduced exhaust back pressure. Lastly, thanks to my team member Uze, Nivishan, Tanabalan, and Muaz, who have successfully completed this project. Thanks also to our lecturer, Associate Prof. Devarajan in this subject. So that's all from me. Thank you.